React Native developers. These beautiful 3D transformations are done using React Native Skia. I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this tutorial, we're going to look at 3D transformations using React Native Skia, and we're going to do it in 3 simple steps. First, we're going to bind a gesture to a simple shape transformation, just like we would with a regular React Native view. We add the rotate X, the rotate Y, and of course, for the transformation to look natural, we're going to apply the perspective. So you see the difference here without or with perspective. And then we're going to do something a bit more advanced. We're going to apply the 3D transformation to a clipping path. So here we have a backdrop blur, and we're going to apply the 3D transformation to the clipping path, giving us this nice 3D backdrop blur. And finally, we're going to pass the transformation matrix to a shader. The format in the shading language is different. So we go from row major to column major matrices. And this allows us to do some shading based on the Z index. And we're going to take advantage of this to do a variable blur based on the Z index, which is going to look very, very cool. I am quite excited about this tutorial because a couple of months ago, we had a tutorial on variable blurs and blur masks. And back then, the algorithm we offered to build such an effect were very poor, to say the least. So instead of redoing a tutorial exactly on the same topic, I'm excited that I can get to use these new shaders in the context of 3D transformations, where we're going to use a variable blur depending on the depth of the 3D transformation. So let's have a look. We are into VS Code here, and the first thing I think I'm going to do is surround the Canva with a gesture handler. So we can create a rotate Y and rotate X value. So I'm going to use the gesture detector. And we need to create a gesture variable. And this is going to be a pan gesture. And I'm going to need two, so let me maybe import this if needed. I'm going to need two reanimated values, one which is rotate X and one which is rotate Y. So rotate X and rotate Y. When the gesture changes, or is it unchanged? I think it's unchanged. We can apply to rotate X the E dot change Y. So here we want to convert movements in points to a radian. So we can just simply divide by or multiply by some sort of a scale factor, which we can decide. I don't know. I just put a random value here. We'll adjust depending on our needs. And rotate Y value, we do the change on the X, right? So if we move from left to right, we rotate on the Y axis. And if we move from top to bottom, so on change Y, we rotate on the X axis. So this looks good. Now we need to apply a transformation. So to see the change, so I'm going to use the derived value. And we can, return an array. And we're going to use rotate X dot value, rotate Y. And apply the transformation here. Okay. So let's have a look. Nothing is happening. I think here I just, because I'm using change Y and change X, I need to apply a plus, and probably I need to invert the axis here, I think. Let's have a look. Yes. So here there's a couple of things which that actually looks okay. So first we need to change, as you can tell, the pivot point to be at the center of the card. So we're gonna add translate, and where is, so I have this. Let me get the center of the card. So I think there's a center function that will give me the center based on a rectangle, and I can, so I have the rounded rectangle here, dot rec. So I can do c.x, c.y, and then minus, okay, c.x, c.y. Oops. So now the pivot points should be correct. Let me use this one here. So yes, that looks good. Now it looks strange because we don't have a perspective, which I can add here. And what I want to do here is that when I release the gesture, I want to go back to 0. So on end, we're going to spring back to 0. And I'm going to need velocity x and velocity y. And so here I'm going to 0. And here the completion looks correct. Okay. So this looks good as expected. And I guess you cannot see my finger here. I mean, this looks nice, but indeed I need to change, I think, to invert the axis here, but now this looks perfect. Okay, and so we can add a simple effect here. So I can make the background black, and I can redraw the rectangle here without the transform. Add a sweep gradient. The center we have, the colors are cyan, magenta, yellow, and cyan. And that's called C, I think. So this looks quite okay. What I can do also even is to add a blur mask, which I think, let me check. So I'm not going to use this one yet. I'm going to use the one from React Native Skia. And blur, let's say 10. Style, solid. Let's have a look. Yeah. And I can even, I mean, this is pretty nice. If you want, we can even inflate the rectangle slightly by 1 or 2 points, like this. Looks like the M1 colors a bit. So this was step 1. Now we can use this transformation and applying it to a clipping path. So we're going to transform a path with this 3D transformation. So let's see, I'm going to remove this and I'm going to use a picture as background, a picture of Zurich. And let's see. So we take the full screen and fit cover. Seems okay. And yeah, we're not transforming a shape anymore. We're going to apply a backdrop filter. And here I'm going to put some white. Yeah, I think something like this with some opacity. And the filter is going to be a blur filter. Blur, let's say 10, I don't know. I think 10 is good. So now this blurs everything, but what we want is to clip. And I think one thing maybe I can try immediately is to do clip directly with the rounded rectangle. Let's see, yeah. But now we want to move it. So it's not going to be, so I'm going to create a clip and I'm going to use the use path value. So use path value is a new hook in React Native Skia that we can use to animate path. And it does so to animate paths efficiently in React Native Skia. And there is a lot of nitty-gritty that needs to be done. So we take care of all of this in the hook. And yeah, so that's the easiest way to animate a path, but that's also the fastest and most performant way to animate a path. So we provide you a utility so you can animate path easily, but also we use it, so we make sure that it's done in a performant manner. And so here we get path, we add the rec, the rounded rec to the path, and we're going to apply this transformation. So we're going to do path.transform, and we have a process 3D transformation that we're going to apply. And I can pass the transformation here. And we can apply the clipping. Oh yes, so you see it's complaining here because I need to use the worklet. So it's a bit annoying because here we cannot do it automatically, like for some reanimated hooks. But now I can apply the clipping path here. Let's have a look. I have the nice 3D effect, but on a backdrop filter. So we apply the 3D transformation to a path. So really fun example. But now let's do the final step where we're going to pass the 3D transformation to a shader and shed the card depending on the depth of the pixel. So let's start with just a simple shader. So we can write shaders just to, I mean, I think you're familiar with this in React Native Skia. We have a couple of videos on this, and we can also use shaders to create, so to have image filters. So here I can pass a custom shaders. It's called a runtime shader, and I'm going to receive the image to filter as an input. So we can create a simple one, and then just to get a sense of how to do the shading, and then we're going to use our variable blur to nicely blur depending on the Z index. So we will create a simple shader from scratch. Yeah, let's do it. Okay. So source, we have the frag tag. So I have syntax highlighting on the, and so uniform, we get the image to filter as an input. Here I don't think I'm gonna use it. We need to return color. Yes, we get the input, and let's say I return cyan just to try. So RGB alpha. Let's have a look. Okay, so far so good. Now we can pass the matrix as a uniform. So we're going to create the uniforms derived value. So we need a matrix. And here we need to, the format of the matrices in the shader is different from the one used in the Skia API. So we used so far row major matrices. Here we need to convert them to column major matrices. I'm actually not sure why there is such a difference, like why shaders are using the column major matrices. But we simply can transform. So this is the matrix, and we convert it to a column major. And do I still need the clip? Maybe. Let's see. Okay. So now we pass the matrix, so which is of type mat4 as an input. We can calculate the z index. So first we need the coordinate, the projected coordinate. So we're going to multiply, yes, the matrix by the coordinate. So here we choose 0 for z. W component is at 1. So that gives us, so now we have the z value, which we can normalize. So we don't know, I'm not sure actually, do we go from 100 points, 200 points, 300 points, back and forth? I'm not sure what's the maximum depth. So we're going to pick a value. I think I used maybe 150, which works great, but here we can play with it, and also depending on the effect we're trying to achieve, we can play with this value. But now we want to normalize the z value, which goes, let's say, from minus 150 to 150 from 0 to 1. So I'm gonna do p equals, so we're gonna take the z value, yeah, something like this. So we're gonna add r and divide it by 2 times r, right? Because we go from 150 to minus 50. So we multiply, we add 150, so we go from 0 to 300, and then we want from 0 to 1, so we divide by 300. And then let's mix it up to see if maybe I use this and pass p. So you see here, the closer it is to the screen, the more magenta it is, and the further away it is, the more cyan it is. So this looks pretty good actually. So we are able to nicely shade based on the Z value. And so what we're gonna do is use this technique now. This was just like a simple shader we wrote to play with, but we're gonna use the variable blur. And I think I was using blur mask from Skia, but now we're gonna use our own custom blur mask here. And I think what I can do is pass the matrix directly. As an animation value. Something like this. Should be so not the blur mask from Skia, but our own custom blur mask here. And so here we have a nice blur. So you see here we have a custom blur, not a blur from Skia, and it looks good. It actually looks slightly better. I think just because here just the way the clamping is dealt with. So it only works, I think, well in this scenario, and also because also we limit the amount of blur you can do. But so we do it in two paths, horizontal and vertical. And here we do the proper matrix transformation from the uniforms. And what we can do now, if we go in the, so this is our custom variable blur shader, which works pretty well, I think, but let's have a look. So instead of using one every time, here we already project like we did. So we have the Z index. So we're gonna normalize again and pass the amount depending on the Z value. So we're gonna take R155 because that was good. And yeah, so amount is Z plus R divided by 2 times R. So let's have a look. That's correct, but here the closer, you see the closer the card is. So if you look at the left side, and now let's have a look at the right side, the more blurry it becomes, right? Maybe we want the opposite. So I can just do one minus. And maybe also one thing we want to do here is to clamp between 0 and 1. So we can just use saturate, which will clamp between 0 and 1. So let's have a look. So let's have a look at the right side. Yes, so you see on the right side is almost not blurry at all. And then on the left side, which is pretty blurry, left side, less blurry, less blurry. So this looks quite okay. So a really fun way to apply 3D transformations also in the context of shaders. Guys, I hope you enjoyed this example. 3 simple steps to 3D transformations in React Native Skia. First, just like we would for regular React Native views, and then we used the 3D transformation to be applied on the path, so we can use it in the backdrop filter. We introduced the use path value hook, which enables us to efficiently use path animations in React Native Skia with reanimated. And finally, we used it into a shader so we can do some shading based on the Z index. I'm really happy because this gave me an excuse to reintroduce the variable blur shader, which I think now is pretty good. The first time we introduced it was a bit of a shit show, pardon my French, but the whole thing was completely buggy and I was so confused about I confused myself with the topic, but now I think we have something really cool. And I also think that we might be able to take this 3D transformation a bit further away if we think about some cameras, some different ways to do perspectives and moving cameras around. So there might be some more advanced examples awaiting us. So I am looking forward to talk to you soon, and until next time, happy hacking.